Welcome to The Explainer. Let's be honest, if you feel like the world of AI is moving faster than you can keep up with, you're not wrong. Today, we're going to break down this incredible race that's happening on every single front, from a single line of code all the way up to the global balance of power. This thought from AI leader Andrew Ng just nails it, doesn't it? It perfectly captures this new speed of innovation. We're not talking about things getting a little bit faster here. This is a fundamental, ground-up shift in the timeline of how we create things. And that, right there, is the heart of the matter. AI development is speeding up at every single level imaginable. It's happening with individual coders, building an app in a single afternoon. And it's happening in this huge geopolitical struggle between superpowers for the very resources needed to power it all. So, here's how we're going to tackle this. We're going to explore it through 4 key stories that really show this acceleration in action. How fast we can code now, the global fight for chips, the wild breakthroughs in the models themselves, and of course, the staggering price of all this progress. All right, let's dive right in at the most relatable level, the human scale. We're talking about what individual developers can suddenly pull off. For a lot of us, this is where the AI revolution really hits home. I mean, picture this. A recent competition where teams were using AI-assisted coding tools to create real working applications at a pace that is just completely unprecedented. Forget days or weeks, we're talking hours, seriously. That's how much time they had, 6.5 hours. In that time, they had to build 5 separate complex products completely from scratch. And look, these weren't simple little apps. Just look at the requirements from one of them. This is deeply complex stuff. Building a tool to analyze an entire codebase's history and understand the why behind the code, that used to be a job for a whole team of senior engineers, and it would take them weeks, not a single team in about an hour. So here's why this matters so much. The entire competitive landscape is shifting under our feet. When a tiny team can basically replicate incredibly complex software in a fraction of the time, that traditional advantage, that moat you built around your massive codebase, well, it's starting to look more like a puddle. The barrier to entry is just crashing down. Okay, so if that's what one developer can do, what happens when you zoom all the way out? All that lightning-fast coding needs incredibly powerful hardware, and the fight to control that hardware has become an absolute global geopolitical flashpoint. This is a high-stakes technological tug-of-war, really. Leadership in AI is seen as absolutely central to economic, technological, even military power. And both the US and China are terrified that the other is going to gain some kind of decisive strategic advantage through hardware. And at the center of this fight, it's chips like these. On one hand, you've got NVIDIA's H200, which was specifically designed to get around US export rules for China. On the other, you have Huawei's Ascend 910B, which is China's best homegrown alternative. And while NVIDIA still has an edge in things like memory, China's pushing its own tech hard, partly by raising security concerns about US hardware, claiming it could have backdoors. And this whole conflict has led to some, well, let's just say whiplash policy. The US restricted sales, then pretty much banned them, then did a U-turn. From China's point of view, this makes the US look like a totally unreliable partner, which has only thrown jet fuel on their national mission to become completely self-sufficient in chip technology. Okay, so while the governments are duking it out over hardware, the researchers are in a whole different kind of race. One to make the AI models themselves smarter, more efficient, and more capable than we ever thought possible. A perfect example of this is a new video generation model from Alibaba. It uses this really clever mixture of experts idea. The best way to think about it is like a 2-person art team. You have one specialist who's great at sketching the big picture, the main shapes and movements, when the image is still kind of blurry and noisy. Then, once the basic form is there, it hands it off to a second specialist who is a master of the fine details, filling in all the crisp textures. It's just a super efficient way to split up the work. But as these models get more and more powerful, this massive question comes up. Are they actually learning, or are they just incredible mimics? It's really the difference between a student who truly understands a concept and can solve new problems, and one who just memorized the answers for the test. And new research is finally giving us a way to tell the difference. And what's so cool is that researchers actually discovered a predictable pattern. Turns out, these models first go through a phase where they just cram. They just memorize raw facts, filling up their capacity. It's only after they hit that limit that they start connecting the dots and begin to truly generalize and learn the underlying patterns. This gives us a whole new way to think about how AI actually works. But here's the catch. Building models that can truly learn and generalize like that requires a staggering amount of fuel. All of this progress we've talked about, from the coding to the smarter AI, it all depends on an almost unbelievable amount of computational power and energy. You know, for the top AI labs, it's not enough anymore to just have the best ideas. You have to build infrastructure on a scale that's, well, it's just mind-boggling. You don't have to look any further than OpenAI. They're now partnering with Oracle for a gigantic expansion of their computing power. So what's the price for that kind of power? How about $30 billion? And get this, that's not the total cost. That's what they'll pay every single year just for the compute. And the price isn't just in dollars. That new capacity is going to suck down 4.5 gigawatts of electricity. To put that into perspective, that is a colossal amount of energy. We're talking about consumption on the scale of a major city. So the big takeaway here is that winning in AI isn't just about algorithms anymore. It's about being able to secure these almost unimaginable amounts of cash and power. And that creates a whole new web of global dependencies, not just on who makes the chips, but on who can provide the energy and who can write the checks. And that's how you get this incredible feedback loop. It all feeds into itself, right? Faster coding tools create this hunger for even more powerful AI models. Training those powerful models demands a jaw-dropping investment in hardware and energy. And the strategic need for that hardware turns into a high-stakes global race. Every single part of this AI ecosystem is pushing all the other parts to go faster and faster. So, from a single developer building an app in a few hours, all the way to a nation trying to secure its energy supply for data centers, the pace of this revolution is just undeniable, and it leaves you wondering, in a race that's accelerating on every single front, what in the world does the finish line even look like?